In this lecture, we'll cover thin film interference and derive a formula for the general case. This is the incident ray and this is reflected ray. This is the ray which is coming inside after refraction and it is getting reflected here at the bottom surface and here it is at the top surface. This ray comes here, gets refracted, so there is no reflection here, no reflection. So points which we have to note is there is a reflection at a denser medium for one ray if we call it X, and Y ray which is coming, it is reflected by the rarer medium. This side is a rarer medium, so there is no phase shift here, but there is a phase shift here of pi. This thing we have to note, and these are the distances traveled by the ray. Ray X travels this. If we take this point as D and this point at C, between point C and D onwards, the path is same, but before D and C there is a difference in path. So path difference is equal to path which is inside the slab, which is AB plus BC, and this has to be multiplied by N2 because optical path increases by the multiple will be n times the actual physical path in any medium. So here it is medium which is n2, so optical path will be n2 times minus path AD, which is the path which is outside. This is the path difference. Now I am not going to the geometry, I am straight saying AB is equal to BC, so twice AB N2 minus AD. AB is equal to T upon cos R, so it is twice T N2 upon cos R, and AD is equal to AC sin I. In this right angle triangle, this is angle I in triangle ADC. So AD is AC sin I and AC is twice T tan R. This is twice T tan R. Because this is AE is T tan R, this is T tan R. So whole AC is twice T tan R. So AD is equal to AC sin I means twice T tan R into sin I. Now put the values, twice T N2 cos R minus twice T sin R upon cos R, and sin I would be equal to, by Snell's law, sin I would be equal to N2 sin R. So sin R is N2 into sin R. So we get twice T upon cos R into N2, 1 minus sin square R, and here we get again 1 minus sin square R under root. So we get twice T N2 cos R I have written as under root 1 minus sin square R, twice T N2 under root 1 minus sin square R. And now replace sin R again as sin I upon 2, so we get twice T N2 under root N2 square minus sin square I upon N2. So it becomes twice T under root N2 square minus sin square I. This is a general formula. As a special formula, when I tends to 0, sin I tends to 0. So special case, path difference is twice T N2. But not always. When the angle is not tending to 0, you have to use this formula. Now another important point which we have to remember here is that because of the reflection of one of the ray, that is ray X is coming like this and Y is coming from the lower side. This is X, this is Y, and this was the slab. there is a phase shift of pi here, so which will cause the path difference of lambda by 2 between x and y irrespective of the path traveled. This path difference is due to reflection of ray by denser medium. So that is a condition. So when we talk about the bright fringe, we have to take into account that lambda by 2 path difference has already taken place. So we should have another path difference which should be odd multiple of lambda by 2, so that we get finally even multiple due to another lambda by 2 by reflection, when that is also added. So the path difference for bright fringe will be twice t under root n2 square minus sine square I is equal to odd multiple means m plus 1 upon 2 lambda. We can write m can be 0, 1, 2, 3 like that. So this is the condition for the bright fringe, and for the dark fringe it will be twice t under root n2 square minus sine square I is equal to, it will be even multiple for the dark fringe. So just this is the inverse of the normal case where we need even multiple for bright and odd for dark, but here because of this pi phase shift which is causing lambda by 2 path difference, the things just get inverted and reversed. For bright you need odd multiple and for dark you need even multiple. And if you take a special case where ray comes almost normal, so twice Tn2 is equal to m plus 1 upon 2 lambda for bright, and twice Tn2 is equal to m lambda for dark fringe. So this is the answer for the general formula.